The spread syntax uses the spread operator, which are those three dots, to create a copy of the object or array. Let's make an example. Let's see, uh, let's create a variable for a student with name John, age 17, and then let's just log this object, and let's also already make a copy of that. So create student copy, and then let's make a change to the property name, and let's log this student copy to see what we have. And also let's log the original because, as you know by now, it's not going to be the same as I have created initially. So if I save that, you can see that I have what we have seen so far. I have student, my original object, being John, age 17. Then for my student copy variable, I just copied student, but actually it's not a copy of the object, it's just a copy of the reference. And then this one is pointing to the same object in the memory, and whenever I make a change to any property, I will have this changed for my copy, but also for my original object. You can see that was changed as well. As we have seen before, the issue here is that I am assigning a reference from another object, and I'm never assigning anything different. I'm just changing one of the properties. As we know, if instead of assigning the reference from another object, I was assigning a new object, let's say an empty one, if I save, you can see that for my copy, I have only the property name because this is what I'm creating here. If I didn't have this line here, you can see the copy is an empty one. But the bottom line here is that my original is never affected. My original is still there. Let me bring back this change to the name. So if I save, my copy has the property name, but it doesn't have the property age because I have never copied that. What if inside this copy I were to reference the variable student? Well, that would not work because if I save, as you can see, I still have my original one intact, it was not affected, but my copy is not a copy exactly because I have the property name that I have created here, but my student object is here. It's just part of my new copy. It's not the copy itself. I just have another key for the student where I am including age and name inside there of my original one. So this is not what I need. I need to create a new object using curly braces, but I need, instead of getting student, I need to get what is inside of student. And that's what the spread operator is for. Inside here, my student variable, before that, I'm going to include the spread operator, which are those three dots. And that's all. If I save, you can see everything behaves exactly as I am expecting. I have my original one with John and age 17. I have name Mary and age 17 because I have made a copy now using the spread operator, and then I have changed the property name to be Mary. So I have the age copied and the property name was changed. As for my original, you can see it was not affected at all for this new copy. So that's the idea of this spread operator. I'm just going to get all the elements that I have here on the first level of my object, and I'm going to spread it through this new object that I am creating here using curly braces. Another thing is that I can break this into multiple lines, just so it looks more like this one, but you can see that as my first option, I am just including a spread of this student object. Then I can make changes later to this. If I don't make changes, let's say I delete this line, save, you can see that the copy is exactly the same. But another thing that I can do is that inside here, whenever I am creating the object, I can still make the spread and also include the other properties or even change. So for instance, I could go ahead inside here and create another property name and say it is Mary. If I save, you can see that my copy has name Mary and age 17 because I had done the spread and then I had changed the property name to be Mary. I could even create a new property. So let's say ID3. So if I save, you can see that my copy has name Mary, age 17, and ID 3. As for my original, nothing was changed from what I have created initially. The only thing here is that you need to be careful whenever you use the spread operator, because most of the time you want to use the spread operator as being the first thing inside your copy. Not that it needs to be, but usually you want that way. So let's say I move this one to be after ID received 3. Let me just make some cleanups. If I save here, you can see that what I have now. For my copy, I have the property name John, no longer Mary, ID 3 that is here, and age 17, it's there. So why ID was included but the name was not changed? The thing is, I can have more than one property with the same name. And whenever I do this, I have name, it will create a property called name. And then I create another with ID 3, it will create ID 3. And then I bring the spread, where it's going to replace name to be John, which is what I have here, and age to be 17, which is what I have here. I could even, for instance, say grade 7. You can see the grade was included here. Or I could even say ID 9. You're going to see that my final object will have ID 9 because I create ID 3 here and then I replace it here to be 9. I know this is all bad coding, but the point is, if you use the spread operator in the middle or at the end, you might end up replacing some properties that you create initially. This is why usually we are going to use the spread operator at the beginning. Then I can replace any properties as I need for this copy. I can include new properties as I need for this object, for this copy, and I will end up with the object that I need without interfering with the original one. So, just as a bottom line, this is what happens whenever I do student copy receives the student. I'm not creating a copy. I'm just creating a copy of the pointer and not the value itself of the object itself. So both variables will point to the same object on the memory. On the other hand, instead of doing this, I just include curly braces and the spread operator. It will use the spread syntax to make a copy. In this case, I will end up with I was thinking initially, where I have student, it's one object, and student copy being a copy of the same object, but an independent one. And that same idea applies to arrays. Whenever I have an array, we have seen that if I assign one array to another variable, I'm just copying the reference and not the array itself. But I could go back here to the code. Let's just create an example. Let's create an array of fruits. And let's say that I want to log those arrays just so I can see what I have created. And let's make a copy, which I would just assign the reference. And if I change the index 1 to be cherry, I can log my fruits copy and I know it's going to be changed. But the original one is that where the issue relies. If I save, you can see my original one had apple, banana, and orange. Then I have created a copy and changed the index 1 for that copy to be cherry. And that's what I had. I had a copy, but the index 1 instead of banana, I have cherry. That works fine. But if I go to my original one, you can see that it was changed as well, again, because they are pointing to the same object in the memory. The issue here is that instead of pointing to the same variable, I should create a new one. And for create a new array, I need to use square brackets. If I save this one, you can see that my copy created a new array. And then for index 1, I am assigning cherry. But since I didn't have anything for index 0, you can see it shows as empty. But the bottom line here is that it doesn't interfere with my original one. You can see that my original one was not changed at this time. And again, what happens if inside this new object I include my original array fruits? If I save, you can see this is not what I am expecting. what I'm doing is that on the first element for this array, it's going to be another array, which, as you can guess, is my array of fruits. And this is not what I want. What I want is to get all of those and be part of this new copy. So what I need to do is use the spread operator here, which will then create this copy of these elements inside this new array, and then I can make a change. So if I save now, you can see that everything behaves exactly as I am expecting. I have my original array with apple, banana, and orange. I have created a copy with apple, cherry, and orange. And my original one is still unchanged. Everything is behaving as I expect. As before, I can break this into multiple lines. We have seen we can do this for arrays. I could do that here. The only thing is that if I want to replace something inside my array, I am required to do something like this. I'm required to change on a separate line and say what is the index that I want to change. However, I would still be able to include this inside here if I want to include a new one. So let's say instead of replacing index 1, I'm doing something like this. I'm creating a copy using the spread from fruits, so it's going to get all the elements and spread inside here, and then at the end it's going to include a new one, which is cherry. If I save, you can see my original one has 3 elements, my copy has 4 elements, the 3 original ones plus cherry, and then you can see that my original one was never affected by anything. As before, I could change the order here. So let's say I want cherry to go first and then spread all the fruits. If I save, you can see that now cherry is my index 0, and then all the other elements are being spread around here. Also, I could go ahead and include any other element, let's say pineapple. If I save, you can see I have cherry, then I spread apple, banana, and orange, and finally I include pineapple. And this is how we can use the spread syntax to create a copy from objects and arrays. Just keep in mind that this is not a perfect solution for creating copies of objects and arrays, because the spread syntax will just create what is called a shallow copy. And depending on the complexity of your object, it might not work exactly as you intended to. But that's a subject for a future lecture.